H2K Infosys provides world-class online IT training, staffing, and software testing solutions to customers worldwide. H2K Infosys, how we are different from our competitors. 100% job-oriented training, hands-on project work, cloud test lab, resume preparation and review, mock interviews, robust syllabus, one-time fee and lifetime access to classes, access to recorded sessions of live classes. H2K Infosys has won the trust of thousands of students worldwide. For a free demo class, visit us at h2kinfosys.com.
It is very similar to having your variables, right? And all your inner classes can access all the values of your class. Okay, so if you have defined any variable out here, you can even access any of the variables. Okay, now the way, if you see, your message loop is able to access the thread message method. Now, where is the thread message method? It is somewhere present in your simple thread itself. It is not somewhere in your here, because the other way out is not possible. Any of the method, if you define it inside your message loop, it cannot be accessed outside. Okay, so it is just something like your local to this particular class. Okay, now the same program, I'm just sleeping for 2 seconds out here. So this is your 2 seconds or 4 seconds. Okay, this is 2 seconds. Now here I'm just trying to start t.start. Okay, so as I said, I can pass that particular thread out here. So instead of creating a thread and then passing the message loop thread and passing it to this constructor, I just directly created the object out here and t.start. So once I start, I'm just saying waiting for the message loop thread to finish. So when I say message thread loop to finish, that means when I started this one, so at some point of time, this is going to be finished, right? So, but I'm just sleeping this for every loop. I am saying sleep for 2 seconds. Okay. Now, at the same time, as I said, you started this at the same time, this is going to get executed, because it is not going to stop the process here. You are going to start an entirely new different thread in a different stack completely. Okay, I'm coming here, I'm checking whether your thread is alive. So if you invoke a method t.isAlive, it will basically tell you that your thread is still alive or not. Okay, now if you see, this particular line of code will be executed once your thread is not alive. Okay, when your thread is not going to be alive, once the thread's execution completes. Okay, so this we have already seen that. The only one complexity I've added is I have just added a string array out here. Okay, no other changes out here. Okay, now once it says your t.isAlive, it comes here and says, okay, it is still alive, then join. So I'm just saying you join. It is something like going back to a line. Okay, so it says, okay, it is still alive, it comes here, again join for 1 second. Okay, it keeps on iterating here. Okay, it joins every after it waits for it is saying it is alive, come back and join after 1 second. Okay, so this particular wait is going to loop unless and until your thread is going to get executed. Okay, so let us just run this program and see what's going to happen. Now here, if you see here, if my patience, now if this particular thread is going to take a long time, more than my patience time. Okay, what am I going to do is I'm going to come to this piece of code and I see that, okay, my patience time is up and the thread is still alive. I want to interrupt the thread, saying that wake up, stop the execution. Okay, and then join. All right, so we'll see this as well. So let me first run this execution. Right click, run as Java application. If you see here, still waiting, every time, each and every time it is just printing the values of this string array. Okay, at last it invokes your finally, because at this point of time it is not alive. So when it is not alive, it basically comes to your loop out here. Okay, but if you see, it is going to wait, it is going to loop, and it is going to take its own time to complete the thread. Now what am I going to do here is, instead of having the interrupt out here, okay, I will just have the interrupt out here. Okay, so that means the moment it says the thread is alive, it says join, and I'm basically interrupting this particular thread. Which thread? Your message loop thread. That is your message loop thread. I'm going to interrupt. That means if suppose this is in your loop number 2, okay, I interrupt this thread. That means there is going to some exception going to happen. Okay, so it is something like I have this as my thread and it is running. From my program, what I'm going to do is I'm going to interrupt, saying that stop the execution right now. So when you stop the execution in between, you would basically get a interrupted exception. Okay. Now here, if you see, there is a exception which has been caught here, and it says I wasn't done. I mean, still I'm processing. I wasn't done, and the state of the thread will be, you will see that. Okay. So let me run this program. So I come here, I say is alive, I say join. Okay. And at the same time, after joining, I just say interrupt. That means interrupt the thread which has already been running. So right click, run as Java application. Right? I interrupted the thread in between. Right? When it came here, I said interrupt the thread. See, I cannot debug this because it is not in my hand right now. Even to show you properly. Okay. Every time the result could be different. Okay. So right, if I say the moment it says t.interrupt, it basically interrupts the thread which is already running, and if you see, it goes to the catch block and it says I wasn't done. I was still running. I wasn't done, and the state of the thread was in your runnable state itself. Okay, so this is the complete execution of this particular program, wherein we basically interrupt a particular thread which is already running. Okay, so you can just say t.interrupt. All right. Now you have got 1 second here. That means you want to join. You are joining the thread every after 1 second. Okay, and here you just say join. That means immediately you join it out here. Okay, I'm just commenting this out. Okay, so you can give some different values to the patient's value, and you can just try to execute from your side as well. All right. Now, when you talk about a thread, what is a thread again? Right, as I said in the very beginning of the session, you want to do multiple processes at the same time. Okay, the same way I can even start multiple threads out here, and each thread is going to execute its own process in its own time. Okay, now let us go back here. Let me see, not this, not this. Okay, now let me go back and run the same program, computer client and the computer thread. Okay, so let me make this pretty simple right now instead of more clumsiness here. Computer client. So what am I going to do? I'll just remove all the other things. Okay, I'll just comment it out instead of removing it. And I'm just going to start 3 different threads: T1, T2, and T3. And on each thread, I can just give a name also. So if you see this, yep.
Yeah, sorry, before going over there, just one quick question. Maybe I missed out. What is the method join means?
Join in the sense you basically, okay, let me just go there. Where is that? Simple thread. Okay. Now, if already a thread is running, okay. So when you are coming t.is alive, you're checking whether the thread is alive or not. So from this execution, you're saying, okay, join that particular thread, and after 1 second, again, check whether your thread is alive or not. So just go back to the thread and join that particular thread. Okay, just join for 1 second. If it is more than 1 second, again, come back and check whether your thread is alive or not. Okay. It is just going back to the queue and saying join that particular thread. So a thread is running. You are going back to the thread and joining it. So that means once the thread is finished, it is your responsibility to do the processing. But you're not doing the processing. Instead, you're joining a particular line, so that once a particular thing is done, you are just joining the process. Okay.
Nice.
All right, guys. Again, I tell you, it needs good amount of practice to understand thread. Okay, it is not as simple as you see. Okay, I'm not discouraging you. I'm just telling you, I'm just alerting you, because if you want to be a good gaming programmer, you have to have a good understanding of your thread concept. Okay, but when you talk about your Java J2E applications, even though you have at least good amount of knowledge. Okay, if you practice these examples, you will be up to a good speed. Or when you talk about in a group or in a team, when you talk about a thread concept, yes, or at least you see when somebody says multiple threads are running, I want to kill a particular thread. What is that, right? Now whenever you see in your application in your server, there'll be multiple things running at the same time. Okay, something goes wrong in a particular thread. Okay, I basically will go and kill that thread. The same way in your particular computer, you have got multiple processes running, right? So if I want to kill a particular process, I don't have to kill the entire, I don't have to shut down the complete system. I will just go ahead and kill a particular process out here. The same thing, there is an option for you to kill a particular thread in the complete server also. Okay. All right, again, I'm just saying you, I'm not discouraging you. I'm just giving you an alert symbol saying that if you want to understand the good Java J2E concept and you want to put some efforts in that, please go with your threads properly. Okay, it's very important for you to understand these things. Okay, it's something like I become a zombie for you and I'm just scaring you guys. Sorry for that. Okay, now what I was doing, I just okay, all right, so I've just got a class. Let's talk about this. I'm not going to disturb the existing program. I'm not going to disturb these things. Let me just revert this back. Okay, I'm just reverting. I've just reverted this back. Give me a sec, guys. Let me drink some water. My throat is paining. See, I have at this point of time, I have started a thread. That means I have told my wife to get me water. Okay, so this is a different thread which I have executed from the main thread, and she is getting me the water. I'm doing my own thing. Okay, here. So this is again a threading concept here. Okay. You guys are laughing? Anyone laughing? If anyone is laughing, then please give me a smiley so that I understand you guys understood this concept as well.
So where is joining here? Where is joining here?
Yeah, she joined. Yeah, she joined me right now. Okay. See, join again, it doesn't matter. It all depends on your functionality again. When you might say join, okay, or you might not even say join also. Okay. But here you're saying join because you want to execute your program after this. Because if you see here, simple thread, what if I don't use this? Okay. What if I do not use this? Right click, run as Java application. Right. So finally came into picture, but still your another thread is still running, right? Another thread is still running for you. But when I use join, now even though if I use is alive and I don't use a join, let's see what's going to happen. Right click, run as Java application. Man, okay. So it says still waiting. I mean, it is executing indefinite time, right? And at last, when it is finished, right? See, if you see this closely, I'm just saying still waiting. That means when you say I'm using a loop here, right? So whenever in a loop, whenever it is a true, it is going to execute infinite amount of time. So, but here I'm just checking whether the thread is alive or not, right? So every time it is going to come here and is checking whether the thread is alive because this takes its own time in executing. It takes your 2 seconds. So 1, 2, 3, 4. So it is going to take 8 seconds. So until 8 seconds, my still waiting is going to execute. Now, if you see, it is in infinite. I mean, sorry, it is not in infinite. Until 8 seconds, it is going to say still waiting. Okay. But here, I want to say here, once you say still waiting, I want to give a join to this. Okay. Alright, so I'm just saying instead of looping it multiple times until 8 seconds, I want to join this particular thread after 1 second again. I want to check, come back again and see whether this particular thread is alive or not. Because I'm just joining this particular thread to the end of the thread for at least 1 second. Okay, right click, run as Java application. What happened? There is some error. So right click, run as Java application. It is saying still waiting instead of looping it completely. It is joining the thread here. So when it is joining the thread, that means this particular loop is not going to get executed every time, every millisecond. Instead, it is going to join the particular thread which is still running. After 1 second, again this is going to get invoked. Is it pretty much clear right now? Madhu, I think Madhu, right?
Yeah. Okay. Yeah, it's clear.
Okay. Now, coming back to the other program. Okay. Where I was test thread. Okay. Now, I am just going to start these 3 threads. Now, as you see, if this is your just your a thread, I can even extend to runnable. Doesn't matter for me as of now. And I've just got system.out.println and printing x. Okay, and here even I will just give who is actually invoking this particular thread. Thread dot current thread.
Jairam, I have a quick question.
Yeah, go ahead.
You're always overriding the run method, right?
Yes.
Or implementing. Are you implementing it, or we?
No, I'm overriding the run method, which is present in your thread class or in your runnable interface. Okay.
Yeah.
As I said.
So what if we don't override? What is the default function? Did you cover that? Maybe
we have to. No, we have to override it. Okay. Because when you start a thread, the thread has to do something, right? When you have your food, you're going to eat that food for sure. So how will you eat? With the help of your mouth itself, you'll eat. Here, when you start, your run method is the only one which is responsible for doing some execution. Okay, if you do not override it, there is no point in having a thread at all. What will you do with the help of this thread? What this thread is going to do, even though I start this thread right now, right click, run as Java application, right? What is happening? Nothing is happening, right? Now, if I want to do something in that thread, I have to have some methods. That is your run method. I cannot give any other method. I can say public void call me, right? So call me will not work out here. We have to override the run method itself. Right click, run as Java application. Okay, so something is running, no doubt, but nothing, your run method is not running. Okay, so in order to do some functionality in your thread, you have to override your run method. Okay, right click, run as Java application. Now, hope that is pretty much clear, right? Is that clear? Was that Rashmi or was that? Sorry folks, okay. Get your own water. Adil says, my thread says get your own water. Yeah, if you say get your own water, Adil, then you are basically, it'll be a complete synchronous process. So once you get your water, then only you will be doing something, because at this point of time when I told my wife to get water, I started a different thread here. Okay. Okay, now here what I'm doing is I'm just saying I'm creating 3 different threads here, and I'm just saying giving a name to each and every thread. I'm just saying start and start. When I say start and start, remove this. Okay, bachelor thread. Alright, so when I say start and start, my assumption should be that when I start the thread first, so Fred should do all the execution first, and then Andrew should come, then Bob should come. But if you see here, there is no particular order, because you're trying to use a single resource out here. right? Who is the resource? Your 4 runnable is my resource here, and all the threads are using the single resource out here. Okay, and everybody are running in its own thread. Okay, so sometimes the scheduler, what it does, it gives the priority to Fred thread, sometimes it gives the priority to Andrew, sometimes to Bob, sometimes to Andrew, then Fred to and Andrew. Okay, so it keeps shuffling, or it is completely dependent on a particular scheduler to which particular thread to give the priority. Okay, you just started your thread, you have no control. As I said, thread is such a concept, such a topic, you cannot guarantee anything at all. Okay, so only thing is, if you run the same program in your Mac operating system, it could be different. Right now, every time I'm getting the Fred here, but it doesn't mean that you always get a Fred here. If I run this program again, right click, run as Java application, it was Fred. See, now it is Bob here. Okay, so you cannot guarantee that which particular thread you start first, that particular thread is going to be executed first. Okay, there is no guarantee at all. Okay, just keep this in your mind.
Hey Jiram, I have a question. So when it started with Bob, right? Then Andrew and Fred and Andrew, and then again Bob, right? So let's suppose I'm doing something in my application, right? So I actually worked on one of the concepts, so that's what I'm asking. So I have to like started a program which is Bob, right? So it's doing that Bob, and then will it stop in between and then start Andrew and again start Fred, and then
no,
again
it will not stop anywhere. Okay, so what happening is, the scheduler first will take the Bob here. Okay, and then Bob does some of his work at the same time. The scheduler will halt Bob, or he will not give any process to the Bob, and he will pick up Fred here in this point of time. Okay, so it all depends on the scheduler, as I said. So it's scheduler job to give the time, or give the process to a particular thread. Okay.
Okay.
Now, if you see, it's all random. You cannot even say what is what. Okay. Now, what I want to make this more consistent. Now, I created a single object here, and the same object I'm giving it to 3 different threads. All the different threads are actually using the same resource out here, and they are running it in their own fashion. Okay, I want to be more specific. So in order to make a thread, once I say that whenever Fred does any execution on this particular thread, okay, I want to completely dedicate this particular thread to Fred itself. So once Fred is done, then only I'll give the responsibility to Andrew. Or it's not responsibility, sorry, to use this term. Then only I'll tell the scheduler that, okay, Fred is done. Now if you are happy on Andrew or you are happy on Bob, you give the control to Andrew or Bob next. So what should I do here? So in that case, I will just say synchronized. Okay, so what did I do? I made my method as synchronized. Okay, so right now let us run this program. Run as the application. See here, once Bob is completing, then your Fred is completing, then Andrew is completing. And again, there is no order here. Andrew may come first, or Fred also may come first. Let me run this. Right. So right now, if you see, Bob has come first. Run as Java application. Anyhow, the Bob is coming first. So as I said, you have no control on this as well. Okay. So in order to make a particular thread synchronized, you just need to use your synchronize in a particular method. So when you say synchronize, what happens is this particular object gets a lock. So who gets the lock? Whoever is starting first. If Fred is starting first, Fred gets a lock on this particular object, entire object. Okay, so when it gets a lock on this entire object, no one can access that particular object, even though 2 or 3, or whether it is your Fred, sorry, whether it is your Andrew or Bob, no one can access this particular object. Okay, you will get a lock. Who will get a lock? Your thread 1 will get a lock. Okay, so based on this lock concept, we will talk about a different functionality right now. Okay, so the functionality is nothing but you have got 2 ATM cards. Okay, and At the same time, you and your friend go to the ATM machine, two different ATM machine. They go and check the balance. So another balance is around let's say $1,000. Okay. Now at the same time, each of them try to get the money back. Okay. So one friend says I'm trying to withdraw 1,000. The other friend says I'm trying to withdraw 1,000. Okay. But you cannot withdraw. You cannot over withdraw things, right? So at that point of time, the first person who basically tries to get the amount, okay, he gets the lock of that particular process, so that your second friend cannot access that. Okay, once the process is done, then when your second friend is trying to access it, at that point of time, okay, he will basically get a wait on that. He will not be able to proceed. Okay, and next when he tries to proceed, he says there is no balance. All right, so we'll see the same concept right now. Based on your synchronization here. Okay, so again, synchronization is one important concept. Everything is important, guys. Okay, in Java, everything is important, right? Which way is more fast? Okay, I didn't get your question, Ajit. Which way is more fast in the sense?
So when you made it synchronized and it first finished Bob and then go to Fred, or
no,
it's more fast than making it randomly go to Fred, Andrew, and Bob, or
right? Yeah, it's a good question. When you talk about synchronization, basically what happens, if I do not use synchronization, okay, so your process, the complete process, irrespective of whether which particular threads gets the access. Here I'm using the synchronization concept because to make it more systematic. Okay, but if I use a synchronization, no doubt your performance is a hit. Okay, so you will always have some slowness in your complete process whenever you use your synchronization. Okay, see here the concept is not the fastness. Here the concept is you want to do a process systematic. All right, now is that answer your question, Ajit?
Yes.
Okay,
thanks.
Now when you talk about there are different classes, there are different methods which are present. Even in your collection, even I didn't even speak about vector. There is a class known as vector. Okay, so which basically if you see here java.util.vector. Okay, so when you compare your vector along with an array list, your array list is not synchronous, but all the methods in your vector is synchronized. Okay, if you see all the method, which is again part of a collection itself. Okay, all the methods is your synchronized. Okay, now what do you mean by synchronized? That means when you do any processing using a vector, no other thread can access the same collection. Okay, so these days no one uses vectors because it is a performance hit basically, and even personally in my project when we were using a legacy program, in that legacy program there were a lot of vectors being used and it was a performance hit, so we had to change a lot of things back and forth. Okay, all right, I don't think I will be completing this. All right, okay, what I was saying, synchronization. Okay, so the concept here is anyone who is feeling bored, we can take a break, or anyone feeling sleepy? No? Yes? No? No? Is it interesting, folks?
Is it more
we will discuss about synchronization and we'll talk about deadlocks. At least it is going to take another half an hour. Okay. All right, folks, let's start up. All right, so I've got an account here and I've got a balance of 50, and I just before even getting the money from the account, I just see what is the balance out here. Okay, and then I do a withdraw. When I do a withdraw, on that particular withdraw, I just minus $10 out of it. Okay, and the maximum I can withdraw is $10 itself. Okay, and I've got a client program, sorry, a client account holder program. Okay, in the account holder program, if you see, this is again implements a runnable, and you have got a run method here. Okay, and this run method is actually what it is doing. It is saying make withdraw. So I have got a 5 loop here. Okay, it is going to loop 5 times. It is going to say make withdraw of 10. So each time it is going to make a withdraw. When you say make withdraw of amount 10, it is going to first check what is the balance. Okay, the amount is greater than or equals to amount. That means, let's say you are saying 10 and the account is greater than or equals to 10, then you can go ahead and do a withdraw. On which one? On the account itself. So you have already created an account object here. On that account object, you will be subtracting the amount. Okay, so it's a simple program out here. So you keep doing a withdraw. So let us go back to the client program here. In the client program, I am having 2 threads. One is a king thread, one is a queen thread. Okay, so this is my king and this is my queen. Okay. Now if there is only one thread, if I just talk about your king thread, okay, so I just say it here and start it here. So when I talk about a single thread, there is no problem because only one thread is going to run here. Right click, run as Java application. So king is going to withdraw, king is completed the withdraw, king is going to withdraw, king completes the withdraw. So what it does basically, if you just go to the account holder, make withdraw here and I just say withdraw. Okay, so king, I'll just say instead of typing it here, withdraw. Okay, king completed the withdraw amount plus the amount will be your AMT. Okay, so if I just run this program, run as Java application. So king completed the withdraw of amount 10, 10, 10, 10. So it 1, 2, 3, 5 loops and the money is gone. Okay, so if I loop it let's say 6 times, so at one point of time I'm checking the balance here. If the balance is not enough, it is saying not enough account in your not enough balance in your account, not enough balance, okay, not enough in account for so and so. Now I'll just change this to 6. That means I'm looping it 6 times and each time I'm getting out $10 out of it. So again go back to the client program and say right click, run as Java application. Okay, so it's at last it says not enough in your account for the king to withdraw. So it is not allowing you to withdraw anything. Okay, now as you know, we have spoken about 2 threads. What if I create a new thread here? Right, so I created a new thread out here and both the threads I'm running at the same time. And if you see, there is in your thread class, there is I'm not even using a synchronized method out here. Okay, so when I'm not using a synchronized method, it all depends on the scheduler to which particular thread to give the access to of this run method. So they keep on accessing this particular account, and at one point of time there will be a message that is your account is overdrawn, right? So if I run this particular program right now, run as Java application. Okay, so let me make this as 7. At this point of time you cannot see the message, so let me make this as 8 or 9. Okay, so my check is something like, I want to check because I'm doing a check out here and saying if the amount is greater than or equal to amount, then only do it, otherwise don't do it. But at the same time both can access this particular if condition. Both threads can access this if condition. Okay, in that case we are going to have a trouble. Okay, so right click and run this application, run as Java application. Still you are not able to see. Now let me do one thing. Let me remove this sleeping concept here. Okay, so go back to the client program, run as Java application. Okay, so when I remove the sleeping concept out there, I basically getting a lot of over withdrawn here. Okay, it says that you have basically over withdrawn the amount, so there is no enough account in that. Now what is the reason? Because as I said, in your make withdraw, both the thread access the same if condition at the same time. For them, this condition satisfies, they go inside this particular if condition and they withdraw the amount. When any withdraw happens, so obviously you will be having, if it is 0 right now, if it is you're withdrawing 10, so it is going to be minus 10. So that's what you're getting it out here. Okay. So at this point of time, if I just say 5 also, I think you should be able to get the withdrawn. Okay. Now, in order to make sure that two threads will not access the same method, okay, I can basically make that particular method synchronized. Okay. Now let us run the same program. Right click, run as Java application. Now at any point of time, you will not get a withdrawn of over withdrawn at all, because you have made a particular method synchronized. In the previous case, I made the run method synchronized. Now I know this is my main transaction which is been happening. Okay, from the run method, you are invoking the main invoking the make withdrawal method, and you are making that particular method as synchronized. Okay, I can even make this run method also as synchronized. Okay, so when you make it as synchronized, that means you are basically giving a lock of this entire object, okay, to which particular thread, any thread which has got the first access to it. Okay, so concept wise, I believe you guys would have understood this. I would request you guys to at least practice these programs, okay, so that you just get a feel of how the thread concept works. Okay, so let's go back to now. Sometimes what happens is you might get into some kind of deadlock situation. Now let us see what is a deadlock situation. Okay, when you talk about threads, you have to be very careful to use a thread, because you might get into some kind of deadlock situation when you do use your synchronized keyword. Okay, so let us go back to your deadlock demo out here and see what is going to happen here. Okay, now let's say there are two resources, resource A and resource B. Resource A is I'm saying that for a person, let's say this is a single my thread and this is your thread. Okay, so I'm saying to the my thread that get the bike, get the helmet. Okay, you do your cycling. Okay, once your cycling is done, then give the helmet and the bike to your thread. Okay, so that your thread also can run the bike, and once he is done, then again you can execute also. Okay, now here I am trying to make a deadlock here. By what I'm trying to do is, the moment I run a thread that is a Todd, or let's say my thread, I basically lock the resource A. Okay, inside what I do is I lock the resource B. Okay, I start both the threads at the same time. If you see here, my thread and your thread, my thread is having the moment you say synchronized. Okay, this is a synchronized block basically. In the synchronized block, I am passing an object. So when you pass an object inside a synchronized block, that particular object gets locked. Now at the same time you're starting this, and at the same time you're starting this. So two things are starting at the same time, because you're saying here 1.start and 2.start. One is nothing but your Todd, 2 is nothing but your Mary. Okay, so Mary started, got a lock. Todd started, got a lock. Now each of the person has their own lock on resource A and resource B. But when I'm coming inside the resource A, I'm already have acquired a lock on your, let's say, bike. So let me just rename this to bike and rename this to helmet. Okay. Now, okay, this thread got a lock on bike, and this thread got a lock on helmet. But what I need a lock on both bike as well as helmet. So for that reason, when after getting a bike, I'm basically going to get a lock on the helmet also. Okay. Now at this point of time, what will happen is there is a deadlock situation which is going to happen, because your Todd has got the access of this bike and your Mary has got the access of the helmet. When they are coming here, they are trying to acquire a lock on helmet, but helmet is already been acquired by another thread. Okay, at this point of time, they keep on waiting with for each other. So when they keep on waiting, you get a deadlock situation. Okay, if I run this program, right now, right click, run as Java application. You see the execution here. It says Mary holds a lock on helmet, Todd holds a lock on bike. Todd waits for the lock on helmet, Mary waits for the lock on bike. So there is a deadlock situation. No one is able to proceed any more further. Okay, so this particular piece of code is not getting executed because even this is not getting executed because the moment it comes here, helmet is already been locked by another process. So this particular piece of code will never execute. So as a result, this will not ever get executed. Okay, so what are we going to do? We, instead of interchanging this one right here, instead of having bike, helmet, bike, I want to do both the things at the same time. So I'll just say bike here, helmet here. Okay, so I'm basically not creating the deadlock situation right out here because the first time a person comes in any of the thread, he acquires a lock on the bike. So when this person also gets invoked, he cannot get the lock of the bike. He will wait. He has to wait because already another thread has acquired the lock on the bike. Okay, he gets a lock on the bike, he gets a lock on the helmet, and then he finishes thing, and then your another thread comes into picture. Okay, so let us just run this program. Right click, run as Java application. Okay, now Mary holds the lock on helmet. Mary is waiting for the lock on bike. Mary holds a lock on the on both the object, that is the helmet and bike, and end of Mary. Once your Mary ends, then Todd comes into picture. Right click, run as Java application. Now if you see, Todd has come first, okay, and then Mary has come first. It doesn't matter. Say, I mean, your printing is different because again, when you say system.out.println, it print in its own thread, so it doesn't matter whether which one is getting printed, but your execution is proper here. Okay, so this is, in order to get rid of your deadlock situation, you have to be more cautious. Okay, because if you run a program which goes into deadlock, you are gone. Okay, I mean, you have to do a lot of R&D to understand what is happening, what is wrong in that case. Okay, so I'm just going to revert this back so that you guys do some R&D on this as well. So we have spoken about a synchronized keyword. We have even spoken about a synchronized block out here. Okay, so whenever you want to make a particular object to be synchronized, then you can pass that object to your synchronized block. Okay, now this is all about your synchronization. This is all about your deadlock. We spoke about even how to create multiple threads. Each thread can do its own task. Now here we have mainly spoken about a thread, and all the thread are using a single resource here. Okay, but again, you have an option that every thread can do its own task and they can give you the output. One thread can read a file, another thread can write to a file, okay, in the same program itself. Okay, now let us see how we can do a thread communication. I want two threads. I want to start two threads, and once one thread finishes, I want to communicate to the another thread. Okay, here forcefully what I'm doing is I'm just saying start and start. Both the threads are starting, but they're not communicating. Okay, who is doing all the process? The scheduler is doing, because scheduler, your complete process, he knows that he got a lock here, so another process cannot run here, right? But this thread is not communicating to another thread. So this is one thread, this is one thread. Okay, so we'll talk about some communication. If you talk about your feeding, your feed, okay, your RSS feed and stuff. So somebody is going to give some message to the feed, and you keep getting messages, right? So that somebody is going to actually communicate to you saying that, okay, I've got a new feed, you read this feed. Okay, now we are going to do a similar kind of application here. We are going to talk about your an application wherein you have got a single calculator and you have got three readers. Okay, so if you can see, your reader is a thread. Okay, your calculator is also a thread. So there are two threads I am running simultaneously. Okay, I am going to start a thread calculator once I start my reader. So first I start the readers. So reader will be up and ready, and then I'll start my calculator. I'll do some calculation and I'll notify all the readers saying that, okay, my calculation is done. Now you go and read the values. What am I doing? I created a calculator. I am passing that calculator to the reader. Okay, And if you see the constructor of a reader, it is just setting the object of the calculator to the variable out here. And in the run method, it is saying C, okay, and it is trying to acquire a lock on your C, and is saying wait. He's waiting on what? He's waiting on this calculator thread. Okay. Now there are 3 threads running at the same time. 4 threads running, but 3 threads, that is a 3 reader, they are waiting on which thread? They are waiting on your calculator thread. Okay. But in your calculator thread, what it is doing? It is in your run method, you are synchronize of this. That means whenever you're starting your calculator on this particular object. So when you say this on this calculator object, you are trying to acquire the lock. Okay. So you got the lock here, you do some processing out here. Okay. You calculate something with the help of your for loop. And once your calculation is done, you notify all the threads. Okay. So it is something like you start 3 processes, 3 readers, and even you start the calculator. So calculator does all its processing, and at last when the processing is done, it will notify all the threads saying that I am done. Please go ahead and read all the values which all things I have calculated. Okay. Now let us just run this program, and I'll just make this sleep. So what am I doing? First, I'm starting all the threads or all your reader threads. At last, I'll start the calculator thread because I want to just give a sleep time to it. Right click, run as Java application. Okay. Now if you can see here, waiting for calculation, waiting for calculation, waiting for calculation. Now once the calculation is done, the calculation is actually saying notify to all. The moment it says notify to all the threads gets they were waiting. Now they have started running now. Okay. If you see a thread, when he is running, he can go to the waiting state. Again, he can go to the running state. Okay. Now when I say thread.wait, it is waiting. And once another thread, because we are trying to do a communication between 2 threads. So when I say notify all or notify, it will basically go and notify all the threads saying that I am done. Now you start your own processing. Okay. So that's what you have it here. Once all the threads are done, you just continue with this process. Is that okay, folks? Did you guys, anyone has got any doubts, or this was too much for you guys at this point of time?
I think it is a little bit too much at a time, and so probably need some more time to digest it.
Right. Now, the only thing you just need to understand here, I believe at least at this point of time, you would have at least made up your mind that you can even run multiple programs from a single program, or multiple threads from a single program. Okay. Multiple processes from a single program. Okay. So this is a small unit of program which you're trying to run. So when you say multiple processes in your computer, so same way you are running multiple threads from a single program. Okay. So at least if you understood this, keeping this as a base, you can learn all the other things as well. All right. So I would request everyone to practice this once. I'm going to check in these files and at least run these programs one time at least. Okay. We can even create a chat application. Okay. You can create 2 different threads, and once a particular thread gives a message, another thread can read. If one thread gives a message, another thread can read. Even you can create a group chat also. Okay. So when I say group chat, anyone pings a message, the same message goes to all the particular person. Okay. So what happens basically in your WhatsApp or any of your social networking, your messaging sites. So when you ping, the same message goes to everyone, right? So it is something like you are having a smartphone. I'm having a smartphone. One of our friend is also having a smartphone. in each smartphones a thread is running who is always going and checking for a message, whether is there any message, is there any message, is there any message. So there are three threads are working on the same resource on a message to check whether any messages are there. If there are any messages, they're picking up the message and they're just displaying it in your smartphone. Okay, so that is again a threading concept. Okay, all right, folks. I would request you guys to at least practice this. It's very important to understand the threading concepts. Okay, so again, I keep on saying please, please, and please practice this. Okay, I'll see you then again tomorrow. If you thanks. What's for tomorrow, Adil? Tomorrow we'll talk about the JDBC concepts. Okay, and we'll just move on. Okay, folks, I think it's too late. I've got one more class in another 15 minutes right now, so I have to start.
H2K Infosys provides world-class online IT training, staffing, and software testing solutions to customers worldwide. H2K Infosys, how we are different from our competitors. 100% job-oriented training, hands-on project work, cloud test lab, resume preparation and review, mock interviews, robust syllabus, one-time fee and lifetime access to classes, access to recorded sessions of live classes. H2K Infosys has won the trust of thousands of students worldwide. For a free demo class, visit us at h2kinfosys.com.